An easy question, and obviously we will use our best available method for this kinds of questions, which is proportionality, because our distance is constant. So a train traveled at 1/3 of its usual speed. Let's say he was traveling at s. Now 1/3 means s upon 3, and reached the destination 30 minutes after the scheduled time. So time taken initially was t. When speed became 1/3, time became triple. So initially time taken was t, and later on it was 3t. So the difference is 2t. That difference is 2t, and the difference in time is 30 minutes because the person was 30 minutes late. That means that t is equal to 15 minutes. The travel time is 15 minutes. So let me assume a speed, because distance is not mentioned, speed is not mentioned. And we are dealing in minutes. So let speed be 1 kilometer per minute. Time taken is 15 minutes. So distance becomes 15 kilometers. Clear so far? On its return journey, the train initially traveled at its usual speed for 5 minutes. 5 minutes at 1 kilometer per minute becomes 5 kilometers. Okay? And then stopped for 4 minutes for an emergency. Then percentage by which train must increase its usual speed to reach on time. So 15 kilometers, may say 5 kilometers is done, 10 kilometers is left. He wants to reach on time, that's 15 minutes. 5 minutes are gone, 4 minutes emergency, 9 minutes are over out of 15 minutes. He wants to cover this in 6 minutes. So distance 10 kilometers upon time 6 minutes gives you 10 upon 6, that's 5 upon 3. That is 1.6 bar kilometers per minute. Okay? Initial speed was 1, now it's 1.6 bar. So 1 to 1.6 bar, find out the percentage change, that's 66 2/3%. And your answer is nearest to 67, and that is the answer. Use an amazing technique to solve this question, which is proportionality. You've read the question. Initial speed is s, time taken is t. When speed becomes 1/3, time becomes triple. So the time gap between these two cases is 2t, which is given by the delay of 30 minutes. So t is 15 minutes. Let speed be 1 kilometer per minute. For 15 minutes, it's 15 kilometers distance, where he has already traveled for 5 minutes, that's 5 kilometers. And there was a 4-minute emergency. 5 plus 4, 9 minutes are gone, but he still wants to reach in 15 minutes. That's a remaining 6 minutes travel time. So 10 upon 6, 5 upon 3. Speed is 1.6 bar kilometers per minute. From 1 to 1.6 bar is an increase of 66.6 bar %, and that is your answer.